So we're looking at solving rational expressions. So we've been working with them. Now we actually start to solve them. So first things first here. If I give you 1x equals 3/5, how do you solve that for x? When you have a fraction equal a fraction, that's when we actually cross multiply. Okay? So since I'm writing horizontally, I'm going to use the yield arrow. Okay, not an equal sign. If you use an equal sign here mathematically, you're not correct. All right, so we're going to cross multiply. Everybody all right? So what's 1 times 5? 3 times x. Okay, how do I get x by itself? So x equals 5/3. All right. So does everybody remember how to do this with your cross multiplying? So the only time that we cross multiply is when we have a fraction equal a fraction. So since we've been working with rational expressions, which are fractions, we're going to be using the same properties here. Okay. So if you notice the second problem here, do I have a fraction equal a fraction? Yeah. Right? I've got a fraction equal a fraction. So I'm going to solve it the same way. I'm just going to cross multiply. So I'm going to take 3 times the denominator across from it, which is 4x plus 5. And that's going to equal the numerator from the opposite side and the denominator across. So you get 3 times 4x plus 5 equals 9 times x plus 1. Everybody okay with that so far? Yes, no, maybe? I don't know. All right, so now, can we solve that for x? So what's my next step? You should say yes, because this is what we did last year. So what's my first step to solving this? Getting rid of what? Get rid of parentheses, so distribute, and what do I get? Equals. Okay, how do I get, or what do I have to get together? All right, subtract the 9x. I get 3x plus 15 equals 9. How do I get x by itself? Subtract 15. So you're going to get 3x equals negative 6. And then finish it off. Divide by 3, right? So x equals a negative 2. So for these, because we're solving rational expressions, we are going to be getting x equals as answers. Okay? So the whole point of this, when we're solving, is we actually want things to be a fraction on one side equal a fraction on the other side, so we can cross multiply. And then it's solving just like we have been all of last year. Okay? Any major questions on this? Yes, no, maybe? An alloy is formed by mixing that's supposed to be two or more metals together. So if you look at bronze, right? Bronze is a copper alloy. It's copper and tin. Would we consider copper really strong? No. Is tin considered super strong? No. But if you mix them together, they actually get stronger. So we have sterling silver, right? Jewelry silver is composed of 80% silver and 20% copper by weight. Okay? So if you buy a silver ring, it's going to be an 80-20 split. How much pure silver should you mix with 15 ounces of jewelry silver to make sterling silver? All right. So this is what your formula should look like, and don't worry, I'll explain it, right? We're looking at it from the copper side. So 7.5% over 100. This is our sterling silver side, correct? Everybody right with that? Okay, over here is our jewelry silver side, which we're trying to turn into sterling. So jewelry silver has 20% copper by weight. So if this is the copper rate, we use the same thing here. So 0.2 times the 15 ounces tells us how many ounces of copper we already have. Everybody all right with that? Yes or no? Then we've got to divide it by 15 plus x, because the x is the amount of silver we have to add in order to make the equation balance. So this is going to be 300, 7.5 times 15 plus x. So to get x by itself, we're going to divide 300 by 7.5, by 7.5, and then subtract the 15. So 300 divided by 7.5 equals that, minus 15 equals that. So we need 25 ounces of pure silver. So do we have a fraction equals a fraction? Yeah. So we're going to just do what we have been doing, cross multiply. Negative 4 times x minus 3 equals 5 times x plus 3. How do I solve it? Distribute. Okay, so distribute on the left. And I get negative 4x plus 12. Distribute on the right. I get 5x plus 15. All right, group up my like terms. Group up my constants. X equals negative 1/3. Everybody okay with that? Done and done? So same thing here, right? Cross multiply. All right, so what's different about this problem? I have a what? I have a squared, so I have to put everything on the same side, make it equal 0, and then factor. So I'm going to get 2x squared, subtract the 11x, negative 6x, subtract the 8 equals 0, and now I can factor. And I know this is kind of low. I'll get my big bulbous butt out of the way in a minute. My brain's like, yeah, I don't know, man. Which isn't good when your brain's supposed to have the answers. You kids! I'd have gotten away with it too if it wasn't for you middling kids. Alright. So everybody here with the factor there, right? So again, if I had to do this properly, everything here is even. I would have divided by 2, gotten x squared minus 3x minus 4 equals 0. Makes numbers easier, right? You can factor the long way like I did. You can use the LaRue method, whatever, as long as you get to here. And then what do we do with our answer? Set each factor equal to what? 0. So x equals 4, and x equals negative 1. So everybody right with where those are coming from? Yes, no, maybe? So remember what we started the year with on solving quadratics? It's still going to kick up. All right. So for this one, what do you notice? What's different about this one and every other problem? 1 minus, right? So do I have a single fraction on the left? No, so I have to get it into a single fraction. So to do that, I'm going to have to get common denominators. So remember the section that we just got through that you guys are still complaining about? This is where we used it. So we're going to do the crisscross across on this guy and get x minus 5 minus 8 all over x minus 5 equals 3 over x. I'm going to simplify on top and get x minus, what is that, 13, right? Yeah. All over x minus 5 equals 3 over x. Everybody all right? You all with me? So now do I have a fraction equals a fraction? Yeah. So now cross multiply x times x minus 13 plus 3 times x minus 5. Simplify. Da 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 da. All right. Again, what do you see as your power? We have an x squared, right? So that means that I have to get everything on the same side. So I've got an x squared minus 16x plus 15 equals 0. Everybody all right? Yes, no? Minus 15 and a minus 1, right? So now I'll set each one equal to 0, and I get x equals 15, and I get x equals 1. Any questions on that? So I hope you don't feel too overwhelmed with this. It's just a combination. Like I said, the thing that's tricky about this year is we're combining stuff we've been working on for over a year into one operator, right? Getting a common denominator. We've been doing that for over a year. Okay? Here we're doing it with rational expressions, which we've been working on for about a week now. All right? Cross-multiplying, multiplying rational expressions, or multiplying any mathematical expression, that's been over a year. Grouping, factoring, solving, all of that stuff is about a year old. Okay? So any questions on the process? Yes, no, maybe? Okay. Check for extraneous solutions. So first of all, does anybody know what an extraneous solution is? It is. But what little word is part of the extraneous? It's not an S. Extra, right? Okay, what does it mean for something to be extra? Or more than needed, right? So for us, what's going on here? So extraneous means it's something that you find as a solution, right? It's a potential value for X. But when you plug it back into the equation, it actually doesn't satisfy it. Okay, it isn't a solution, but it shows up on our list of solutions. Okay, so whenever you see the word extraneous, that basically means solve it like normal, and then at the end, check your answers. That's all it means. Okay? Yeah, like they're going to say solve the equation, check for extraneous solutions. So your first step is solve the equation. That's all we're doing. Solve the equation just like everything else. The only added step is once you get your X values that could solve the equation, you got to plug them back in and see if it actually solves it. That's it. Because when they tell you there might be extraneous solutions, that means, hey, you might get an answer that looks like it's an X, but it actually doesn't satisfy the actual equation. Okay? It's kind of like the whole false cognate thing, right? You guys remember that from foreign language? Or something? Okay, never mind. Like, my favorite false cognate is poisson. Yeah. It's spelled poison, P-O-Y-S-O-N in French, but it stands for fish. So you look at it and it looks like poison. So you think you know what it means, but it means something different. That's a false cognate. Yep. My Spanish teacher in college used to sing a song about Bolivia. Well, actually, it was the Bolivian national anthem. Okay, so we have one fraction on the left, right? We need to get a single fraction on the right. So my left-hand fraction does not get touched. My right-hand fraction, what's the common denominator between x plus 3 times x minus 3 and x plus 3? X plus 3 times x minus 3. Is everybody okay with where that's coming from? Right, what's shared between both denominators? The x plus 3, so that comes through, and then anything left over has to be included, right? All right, what's the difference between this denominator and this denominator? Because we're not multiplying them together, because that makes things nasty. So we're looking for least common multiples. So what we do is we look for anything that's repeated under both bottoms just comes through as a single piece, and then anything left over comes through as its own piece. All right, so what's the difference between this bottom and this bottom? Is there anything different? No. Yes or no? All right, so now I can cross multiply. So I get 6 times x plus 3 times x minus 3 equals 4x squared plus 12x. I know that was really mature of me. Times x minus 3. All right, are there any factors in common here? X minus 3. So I'm going to divide each side by x minus 3 and get them to cancel out from top to bottom. Tink, tink. Tink, tink, right? And then I'm going to multiply and get 6x plus 18 equals 4x squared plus 12x. And again, does everybody see that my biggest power is a 2, right? So I have to put everything on the same side and then factor. So 4x squared. Yep. Plus 18. Now, I don't guarantee anything, kiddo. If you all work on a regular daily basis, yeah, you'll be fine. All right, so, sorry, there's an equal 0 here. All right, so is there anything I can factor out of these three? I can divide everything by 2, right? And that's going to leave me with 2x squared plus 3x plus 9 equals 0. And then I'm going to factor this down with the LaRue method. So that becomes x squared plus... You can, if you can factor it out of that, yeah, you're fine. I divided everything by 2. No, not yet. Yeah, that's how I... Oh, yeah, I'm using the LaRue method. Take A times C. So, it's going to be a 6... Ooh, no. Did I miss a sign somewhere? Yep. Crap. This should be a minus 18, y'all. Alright, that looks a lot better. So two numbers that multiply together to get 18, but when you subtract them, you get 3, so 6 and 3. Bigger one is positive, negative, right? And if I multiplied by 2 at the beginning, I have to divide by 2 now. So I divide these by 2. So you get x plus 3 times x minus 3 halves, or 2x minus 3 equals 0, like that, right? So you get x equals negative 3, x equals 3 halves. But now what you have to do is actually take those and plug them back in. So, like, what happens if you plug in a negative 3 here? What's negative 3 squared? 9 minus 9 is what? Can you divide by 0 in a fraction? So this is one of our solutions, but can it actually work? So that's what they mean by extraneous.